Now let's look at how we can count information in the source tree and add these numbers to the result tree. My confusion with XSL number when I first worked with XSLT came from the designers conflating two different functionalities into one instruction. Once I understood that there were two different things possibly going on, I then understood this instruction better. So I want to focus first on this value attribute, because when the value attribute is present in XSL number, the processor does one kind of behavior. When the value attribute is absent in the number instruction, it does a very different behavior. That's the difference, and it took me a while to understand what was going on. When we use the value attribute, we have some expression here that gets evaluated to a number. That number is rounded to the closest whole number. When we have a format token, which is an attribute value template, we are telling the processor that we want to represent this number, this rounded number, in the result tree using a particular expression, or a particular type, a particular way of expressing the numbers. In this example down here, this is very common when I am numbering list items. Because if I have pushed all of the list items at my style sheet, the select for those list items will have the values between 1 and last representing all of the list items. My XSL number use here passes the position function as the value, and the token lowercase I tells the processor to add that position to the result tree using lowercase Roman digits. And I don't have to be the programmer to convert a number into lowercase Roman. I just ask the processor, please use lowercase Roman in the presentation of this number in the result tree. Well, when I don't use the value attribute, the processor begins counting nodes in the source tree. It counts nodes, it comes up with a count, and you then you are asking the processor to add that count to the result tree and possibly format that with a token to indicate how it appears. The easiest way to use XSL number is without any attributes. And this will count the current node amongst its like-named siblings. So, if I am at the third chapter node of the source tree and I use XSL number, it will look at all of the preceding sibling nodes. There might be a title, there might be other kinds of nodes, but it looks amongst the like-named nodes, so it looks amongst the chapters. It sees that it's the third chapter in the set of siblings for that node. So it adds the number 3 to the result tree. When we don't supply a format token, it just uses simple digits. So that's the easiest use. Count the current node amongst the like-named siblings. What if the current node isn't the node we want counted? In version 2, we can reposition ourselves temporarily for the purpose of this instruction. We can select an ancestor, and from that point of view, the rest of the attributes apply with our node temporarily relocated up to where we want the counting to begin. That's only available in version 2. There is some behavior in both versions that we can rely on, though, by using the count attribute. This is a union list of patterns, and in this list of patterns, the processor takes a look at the current node and asks, is the current node in the nodes being counted? If so, it just goes ahead and continues with the process, adding the number of the current node with all of the properties that apply. If, though, the current node is not what is being counted, the processor begins walking up the tree until it hits the closest ancestor that is being counted. And when it hits the ancestor being counted, it then counts amongst the siblings. But it will count all of the nodes in the pattern amongst the siblings, not just the like-named node. Not just the like-named node. It will count all of the things being counted. I'm going to depict this in a diagram in a few slides, and we'll get there and talk about that. Well, the from attribute limits how high up the processor goes up the ancestry looking for a node being counted. How high up does it look for a node being counted? This is very useful for book-wide numbering, and we'll see that in a diagram. The next attribute is level. There are 3 values for the level attribute. The default value is single, and when I use XSL number without specifying level, as I said, it counts amongst the siblings. It counts amongst the siblings only. Here in the second example, notice I am counting the union of paragraphs and figures at a single level. Now this is redundant to say it here, but it might help the maintainer that you are explicitly looking at a single level in the tree for all of the paragraphs and the figures. Well, the processor is now looking amongst these siblings. If you have para, para, fig, para, para, those will be numbered 1, 2, 3, 4, 5, because all of the things being counted participate in incrementing that counter. So we are matching paragraphs, matching figures, each one constructs a bit of the result tree, and we use XSL number of this union in both of those. Then at each time we will be including all of the things being counted. It's very helpful. Level equals any will not just count the siblings, but it will look all the way up to a specified from. And if you don't specify from, it goes all the way up to the document element. And this is looking at all of the preceding nodes back to the document element, or back to the closest ancestral element indicated by the from attribute. This is great for book-wide numbering. Think about figures. I am publishing a book. I've got multiple chapters. A couple of the chapters have figures, but I want book-wide figure numbering. If there are 2 figures in chapter 1, I want them numbered 1 and 2. Perhaps chapters 2 and 3 do not have figures. In chapter 4, there's a figure. I want that to be figure number 3, because the first 2 figures were chapter 1, and this is the next figure in chapter 4. Well, I can't use level equals single because that only counts amongst the siblings, and those figures found in earlier chapters are not siblings. By saying level equals any, then I can, the processor will go all the way to the beginning and count all of the figures and add to the result tree that this is figure number 3. It's a very handy construct.